Good morning.
Good morning, Casey.
Just testing my audio.
Yeah, your audio is good.
That's good. They're paving the road in front of my street. Hopefully, they won't be making too much noise while I'm presenting. I'll have to
Your
call
voice
the
is
mayor.
breaking.
What?
Your voice is breaking a bit.
It is? Maybe I'll get closer to the mic. Is it better now?
Yeah, it's a bit better.
Yeah, I'm not on the Cisco VPN, so it should be just direct connect over Google Fiber to the fastest link that they have.
Engine, can you hear AC well? Because on my side, it's really breaking.
Ying Zhen? Can you hear me now?
Yes.
Yeah, Jeffrey has said, I think his issue is mine. Okay, anyway, if people can hear you well in the...
Yeah, it's quite good. Let's get started.
Okay, looks like it's my problem. Let me try to shut off the video. Hopefully will help.
So let's get started. Good morning,
Okay,
everybody. Yeah. So welcome to Rtgwg session. I'm Ying Zhenqu, and I have my co-chair Jeff Tansera online. So we'll start the meeting now. We have a very tight schedule, so we'll try to keep the agenda. So people speak, please try to keep your allocated slot. Jeff, you want to start the chair slide?
Yeah, hi. Welcome to Philadelphia, everybody. Unfortunately, joining you remotely. It's too busy. And it's great to see people finally coming in. And welcome to Routing Working Group, IETF 114. Note well, all your contribution to IETFs are you agreeing to IETF policies and processes. Please read note well if you haven't so before. In-person participations. Please sign in into session with Meet Echo Lite client. Please use Meet Echo to join the microphone queue. Please shut audio and video off if you're not using online version. You see we have issues with bandwidth, so save bandwidth. And most importantly, wear mask unless you're actively speaking to the microphone. Given issues with microphones, please come as close to mic as you can. Remote participants, again, please shut your audio and video unless you are speaking. And we highly recommend it to use headset. IETF policies, please read RFC 8179 so you know them. Specifically to Routing Working Group, we will call for IPR every time draft progresses from one stage to another, and unless each and every author and co-authors have responded, document will not progress. So let's take a look at what happened last couple of months. We've newly adopted document, the VRRP RFC. Thanks for working on it. Existing documents, we closed working group plus call on RIP extended. It's on me to progress document further. BGP peaks is pending AD review. There's some work going on. We are trying to reconnect with Stefan to work on it. ATN BGP, some reviews being done. We'll start working group plus call soon. TILFA still being reviewed, and QoS model will get updated today. The agenda for today is we'll get updates on working group documents, YANK model, dynamic networking, and AC will talk about updates to VRRP. We will have a revived working group document. Thanks, Jen, to start working on it again. It's the destination source routing. We've got great research topic on framework for evaluation of performance of routing protocols. Really interesting work, and actually, Tamada been doing really a lot of research, and hopefully you'll see him not only today but going forward. And there's a lot of new work you will see. And we are planning to at least have one interview, maybe more, mid-September. So stay tuned. And we can move on presentations.
So the first presentation is the QoS Young model. I assume you should have the slide control now. Please go ahead. Asim? Hello, Asim? Can you hear me?
You're on mute, probably. Asim, you're on mute.
We can now hear you, Asim.
Please unmute yourself.
Okay, maybe we do the second one first. Okay.
Asim, do you see the slides? Can you?
So I guess we'll do the second presentation then. Asim, maybe you can figure out what's going on.
Good morning. Okay, so this is network to cloud, and this draft has been on for a while in the RTG working group, and there are quite a few work recently in IETF, so many people told me should finish this, so that's why I'm coming back. Next page, please. So we haven't been here for a while, so we added a co-author from Azure Microsoft, and he brought in a lot more problems. And so we try to focus the problems to the routing area, the problems which can be addressed by the routing area. There are many, many problems in connecting to the cloud. So we're not being able to solve all of them. Many of them are gravity problems, just not being able to solve by us. So we also revised the gap analysis accordingly. So here I'm just, next slide, please. Sorry, it's really hard. I can take this off, right, when I talk? Okay. One of the big problem in cloud data center is the workload in the cloud data center are connected to many, many peers, many parties. So one of the problems experienced is the BGP mismatch, configuration errors. You have parties in different places, like configuring the BGP capability, there's a mismatch, and there's also notification issues and causing one party to drop. If you have the workload in the cloud and in the on-prems, you want to create a VPN, you want to do the BGP connection, like how do you create the BGP consistent configuration on both sides, like BGP over IPsec configuration, that's the issue, making it not be able to do it very consistently. That's one problem. Next slide, please. Second issue is when the cloud gateway data center is connecting to many sites or pods, pods go sometimes go degraded or go dark. Actually, it's not uncommon that there's fiber cut or there's a power outage or there's overload and causing one side to go dark. And with that, when that happens, large number of routes will be need to be switched by the ingress router. So with today's sending route withdrawal message, there'll be large number of messages. So they will need a way to be able to notify to the ingress router of a large number of routes being impacted or need to be switched. So that's another problem we recently added to the draft. Next page, please. For the cloud data center, like mini edge cloud data center in the 5G domain, encounter problems of instances being instantiated in multiple locations, actually very close in proximity. So the routing distance alone actually is minimal, much smaller compared with other factors like site capacity, site capability index, for example. Another issue is the source, the user device, UE. When they move from one cell tower to another cell tower, they may maintain the same IP address. So you will encounter of same source address actually coming from different ingress routers. So that's another problem added into the cloud network, connecting the cloud. Next page, please. Another issue is when you have hybrid cloud, right? You have instances cloud instantiated by, hosted by different cloud providers, and different providers may have different net functions. So when you have a CPE connecting to different sites managed by different cloud operators, the net can be different, function can be different. So when we establish a connection, like for example, establish SD-WAN connection, you will need to be notified the net feature, like what kind of net it support. So that's something, another problem which haven't been defined yet. Another thing is discovery. Okay, so you have instances instantiated in multiple locations, and how do you quickly be able to identify what are the possible locations where your instances are located? That will help the on-prem router to be able to efficiently or quickly switch the service from one place to another place, or be able to optimally choose the most optimal location for the intended services. Next one. And then the DNS, well, this not intend to solve DNS problem, but in the context of routing, uh, there are lots of resources you extension in different cloud operators, and your service, the resource are local to particular enterprise. So your service, like your load in cloud A, may need to resolve address which is not visible or not located in that particular cloud operator. So the DNS, you have to set up the policy so this DNS query will be routed back to your on-prem DNS. And then the on-prem DNS will be able to locate where is the next cloud operator, where the actual instance is. So from the routing perspective, how do we make the instance, the services in one cloud talk to another cloud? How do you resolve the location? That's another problem with DNS. Okay. Another issue with DNS is the client itself may cache the DNS query. So if, like, say, for example, your today's instance is no longer like a single connection. You connect to A to B. The B you want to connect to is usually located in multiple places. So when one place, one location or site pod is having a degradation, for example, how do you tell the client to switch to the next one? So if the client keep the cache, make it very not very convenient for the client to be able to initiate the switch. So that's why when we have those router at the ingress router, if they get notified instead of client, then they will be able to switch the service to the next site more optimally. Next one. And then here's the gap analysis. So with those problems, this gap analysis, we made some changes. One thing is about many forwarding is based on, even though they use IP address, the IP address is not quite the same as before, because each IP address may represent a cluster of instances. Like, for example, if you want to do some kind of application-based routing, you use IP address, but the IP address represent many instances, and they are located in many places. We need a simpler way to represent a large number of services when there's a site failure. Actually, that one has been covered before. Also that you may have different connections. You may have the VPN MPLS connections. You may have the connection over the public internet. So the instance can be connected in many different ways. Next, please. Here's just another summary for the routing area. So the path management, right? So when there's virtual CPE extension in the cloud can be reached by multiple paths from the routing domain, how do we optimally select the optimal egress router to reach to the optimal location? That's something need to be considered because that one requires not only just the traffic path itself, you may need some destination location like matrix to measure different destination in terms of performance. And also that we need in the control plan, right? We need to advertise the network condition connecting to the virtual nodes within the cloud DC. There's also issues of when we aggregate traffic over the private path and over the internet path. And there will be, when you have the port facing the internet, there will be security issues. And also, how do you indicate different kind of paths available for transporting? Today in the BGP tunneling cap doesn't really indicate that one client route can be aggregated over public internet or over private or both, or give some kind of policy. So that's Next page, please. So, so this draft has been, two drafts have been in the RTG working group for a while, and I'm hoping that people can give some more reviews, and we want to call for working group last call. Thank you. Any questions?
Hi, Alvaro Rotana. Speaking as a working group participant, thank you for doing this and for documenting the requirements and the use cases and the gaps and everything else. If I understood you at the beginning, you said that you added some new information.
I'm sorry, I can, maybe you can take the face mask, I cannot hear.
If I understood you at the beginning, you said that you had added some new information to the drafts?
Yes.
Right. So what I would like to suggest to the working group is that documents like these, I think are very important because they're going to guide work on actual solutions. I know there's an edge discovery draft in IDR that references the problem statement and the gap analysis. However, publishing these documents as SRSCs means that the gap analysis and the problem statements are frozen. There's no opportunity to add more problem statements or to update the gap analysis. As we solve problems, hopefully the gaps are going to be closed, right?
Right.
Or
yeah.
maybe we identify new gaps. So what I would like to suggest, again, as a working group participant, is that we maintain these documents as working documents in the working group.
Okay.
Maintained periodically, so that they're not frozen in time today, right, or whenever we get to publication, so that they can remain useful for solution work.
Okay, thank you for the suggestion.
Also, since there are new information added, so please review it.
Yeah, okay, so the key information we added is in the first 2 pages, is the BGP mismatch, when the party is peering with many more peers. It's not like traditional BGP, which you have pre-agreed policy with your partner, you may have negotiated policy. And here, when the cloud gateway established BGP, there will be many more. And so another one is the number of, actually that other one is partially covered, but we enhanced it to make it more formally stated, like when you have a site, a pod goes dark or degraded, how do we indicate to the ingress router to do the efficient switching. So I hope people can have
Linda,
time to review it.
We have more people in the queue for questions. Chongfeng, go ahead.
Unmute yourself.
Chongfeng, we can now hear you. Tianji, maybe you want to speak instead?
One question regarding a slide, probably the 3rd or 4th one, is showing a picture going from Microsoft area going to public and the provider network. Yeah, for this case, actually there's another one is instead of the provider or public, there's the 3rd case, and the cloud provider will have its own backbone. So in that scenario, you may not have so many failure cases as you described. Thank you.
Okay, thank you.
Thank you, Linda.
Okay, that's it. Thank you.
AC, please go ahead.
Okay. I'm AC Lindum, and along with Aditya Dogra, we're doing the VRP version 3 Viz document. That's currently RFC 5798. I just wanted to say that a lot of times, you know, you have people, you want the right people to do these biz documents. And Aditya is currently the lead for the for VRP versions 3 and 2 on the iOS XE, Cisco iOS XE family of networking products. So he's qualified. And as for myself, I've implemented VRP version 2 at 2 different vendors. And for VRP version 3, I put proprietary constraints into it for SD-WAN integration. For instance, whether or not you have an SD-WAN connection, you have a connection to the controller. If you don't want to allow yourself to a master state. So I think we're uniquely qualified to do this. Next slide.
You have control.
Oh, let me see if I can figure this out then. Yep, that worked. Okay, primary motivation for this is not only, well, the first one is the IETF has adopted the NIST standards for inclusive language, which and those of you familiar with the VRP protocol know that it uses master, and that just about changed every page. And at the same time, Cisco and other vendors, we really want to change all our code and documentation to also have inclusive language. As a matter of fact, if you go to a Cisco document now, you'll see on the first, an online documentation, you'll see our commitment to using inclusive language in all our documentation. So, for some standards, it's easy to just do a document that updates it. But in the case of VRP, it seemed like every other paragraph, the concept of master and backup was so much part of VRP that it changed almost every other paragraph. So we went ahead and did this. And we came up with active because, I know that in other HA type protocols and standards, the natural corollary of backup is active. Now, it was less, and as far as the standard is concerned, we figured, well, we might as well backup if we can and have the least intrusive change. So that's why we did that. We also changed some instances of black hole to talk about advertising reachability yet dropping the packets. So that was the main impetus, and we probably wouldn't have done viz of RFC 5798 without this motivation. Next slide. Oh, I guess I have control. I'll blame it on COVID. Additional changes. First of all, I migrated all to XML version, RFC to XML to RFC version 3. So it uses all the new tags and everything. And that seemed to that sounds like an internal change, but it seemed to result in better formatting just by making that switch. There were a number of errata open on all the finite state machines, and we fixed all of those. And then I went through and I did editorial changes. There were actually some spelling errors and some lots of sentence fragments and run-on sentences, and I tried to get rid of those. And I also tried to use, there was also some inconsistencies in the use, just in changing master everywhere. I saw there was inconsistencies of when it was, how it was phrased and whether it was master router with both capitalized or one capitalized or everything. I made it consistent. And so there's a lot of, I believe, at least I believe, since I was the main one responsible, I believe I improved the readability of the document. Also, thanks to a comment from Pascal Touvert, we now recommend for IFEB6 that both the master and backup accept unsolicited neighbor advertisements, as is recommended in RFC 9131. This was a recent change. This was just changed recently in received. We now recommend that validation is done on the maximum interval so that it matches when you receive VRP packets. For backward compatibility, we do not discard the packets because in RFC 5798 it doesn't do that, but the mismatch is logged. We removed. There were appendices that talked about FDDI, token ring, and ATM LAN emulation. Those were removed. We kind of Cisco has pretty much put all those products, all those technologies end of life. It didn't seem like it was necessary to carry these appendices into the future. I beat up the security considerations, and we'll probably, as we go through the AD and IESG reviews, I'm sure we'll beef them up even more. And thanks to some comments from Donald Eastlake, and I improved the IANA section. Next slide. Oh. Okay. What I want to do is get some additional reviews. Like I said, I've gotten some good reviews from Drew, Pascal, and others, like Donald. You can look at by the way, anybody who did add it, gave me a substantive comment. I put their name in the acknowledgements. And so I'm looking for some more good reviews. It's a working group document now, so we'll give it a little time to settle, and then I'll probably start pushing to see how ready we are for a working group last call. I'm also going to, Aditya and I are also going to do, both of us, like take, a couple hours and both of us go through it line by line and look for any inconsistencies. As far as taking VRP version 3 to proposed standards, I'm not going to do this. The reason is, at this point, I get asked to do a lot more than I have time to do. And this just isn't a priority to me. So I'm not going to do this implementation survey and report to get it, consider moving to internet standard. I'm not going to do this. If somebody else is interested in doing this, that would be welcome. Anyway, and then working group. So the next step would be working group class call and publish so that vendors are comfortable making code changes and documentation changes. That's it. Oh, I was gonna say, well, I'm not interested in this. I'll probably start work once I get like a weekend or something, work on the Yang document, start looking at revisions to that so that we can change the terminology in the Yang document. And I'm hoping Aditya, I don't want to speak for him, he might tackle the MIB because we have at Cisco, we have an implementation of the MIB as well.
Hi, Andrew Alston, one of the routing ADs. AC, I just want to say a big thank you for this, because I think from my perspective in my role as AD, when you get a comprehensive review like this that fixes all the issues, etc., it's a lot easier than reviewing tons and tons of erratum, which fix things, etc., and it makes the documents better. And I know that it's a lot of work to do a document like this, and I just wanted to say that from my side, in my role as an AD, this type of work is really appreciated, and I wish I could see more of it. So please keep going, and thank you very much.
Thank you.
Alberto Rotano, Routing AD. Just a couple of comments on the process itself. It is not a requirement to publish an implementation report to move to internet standard. So it's nice that the working group discusses the fact that this is deployed and used and, et cetera. But as we used to do years ago, where we had to publish line by line, each must and should and everything else, we don't need to do that anymore. The main thing, however, is for the changes from proposed standard to internal standard to be minimum. So I noticed most of what you're doing is editorial changes. You mentioned a couple of technical changes, adding something for IPv6 or something else. If we can justify that those are minimum changes, then it shouldn't be a problem as long as it's documented in the Shepherd report, for example, that there's pervasive implementation and et cetera. So just keep an eye on that. Don't make too many changes, especially technical changes, so that if the working group wants to move this to internal standard, then there's no opposition to that. Thanks.
Okay. Thank you for working on this document.
Thanks.
We'll move on to the next presentation.
Yeah, maybe I'll start a thread on that if we don't have to do that. Like I said, every other paragraph is changed because of the editorial changes. But I know exactly what's changed, and everything I've changed, there's nothing that's not backward compatible, and it's mainly just recommendations that are changed technically. And I don't think anybody would argue with the things that I've done anyway. All right, I'm gonna under the mic.
Okay. So I think you want to try again. Or
Yeah. Can you hear me now?
Yes. Go ahead.
Okay, awesome. I believe I had some browser problems. I believe now it's working fine. I have the control, right?
Yeah, you can
Okay.
flip through the slides yourself.
Awesome. Okay. Hello, everyone. My name is Asim Chaudhary, and I am going to provide updates on QS Yang model. So as promised in the last IETF, we have worked on reducing the number of feature statements. Primarily, there were too many feature statements which were causing interdependencies. We have reduced the number of feature statements from 19 to 5. By doing that, we have simplified the model to a great extent. Also, we have kept only those feature statements which are very, very specific to particular vendors and are not part of any particular deployments, typical deployments. Going to the next one. So we have also worked on reducing the number of modules. As I will describe in the later slide, how we have achieved that and what are the advantages of doing that. Also, as promised in the last IETF, we have added the operational model to the Yang model. We felt very, very strongly that as part of the configuration model for the QS, we should also add the stats counters for it to be able to complete. And so we have worked on that to add the counters also. Also, we have added the QS classifier and policy configuration examples, and we have added to the appendix section of the draft. Also, we have worked on few more Yang doctor comments, and based on those modifications, we are able to come up with the 08 version of the draft. Okay, so if we look into our current QS Yang modules, we have combined the QS policy, classifier, and the target module into a single module, and we call it as a traffic policy module. Now, the advantage of having traffic policy module is that any particular traffic-related policy can make use of this module as a base module and can augment or create their model of their own in a very, very simple steps, as I will describe in the next slide. Now, all these blue boxes like QS section and the traffic policy, These are base module, and the orange boxes are derived modules. So for example, the diffserv policy we have created by stitching together QS action with the traffic policy and adding some kind of a match criterias. Similarly, for queue policy and scheduler policy, we are able to come up with a simple modules. Okay, so if somebody has to create a new policy module, they can easily make use of the traffic policy module, which we have added as part of this draft. So these are the 5 simple steps which somebody has to follow. For example, somebody has to create a new policy module of the type policy forwarding. So first they have to define a new policy type. Second, they have to define the classification criteria. Like, for example, we have given a flow tag criteria here. And then next step will be to come up with a set of actions, like a next hop action here. And then number 4, number 5 steps will be augmenting those classification and the action criterias to the traffic policy module. And that is pretty much it. Somebody will be able to come up with a new policy definition or policy modules. Also, to describe a little bit about the operational module. So the operation module in COS consists of a COS interface stats container, which is augmented to the IETF interface module. It has per direction QS counters, and it consists of tagged and untagged counters. Now, the tag counter, also called name counters, are either of the aggregated counters or the non-aggregated counters. So whenever the counters can be combined together, these are aggregated counters. And when they cannot be aggregated together but are tagged with the same name, for example, we have classification, queuing, as well as the metering counter. They are tagged together but cannot be combined. So those are of the kind of non-aggregated counters. Whether it is tag counter or untagged counter, they have to be of type classifier, meter, or the queues counter. So as a next step to the draft, we will be working on the remaining young doctor comment, and hopefully we should be able to take care of most of the comment by the next IETF. Thanks. Any questions?
So we don't have people in the queue. I think
Okay.
please continue to address the comments. Thank you for working on the document. We'll move on
Okay.
to the next presentation.
Thank you.
Good morning. I'm Jen, and I was standing here back in 2016 talking about enterprise multi-homing in IPv6 and how destination source routing is supposed to help us with that. And recently I got a strange feeling that nothing changed in the last 6 years. So I talked to David. And next slide, please. So yeah, apparently we did have a draft about changes to the routing, which would allow the routers to take the source addresses of packets into account while making routing decisions. And the draft was actually making, I think, reasonably good progress. And the authors even requested a working group last call, but I did not find any evidence that it happened. So the draft died peacefully, 3 years ago. And now I have some interest in making that stuff finally happen. So we revived the draft recently, basically resubmitted as it is, with just adding 2 more authors And yes, I don't know if you read it, but a lot of references needs to be fixed, and I'm going to fix it in the next revision. Next slide, please. So just to remind you what it's all about, right? There are multiple cases like IPv6 multi-homing in enterprises using providers' address space. Actually, multiple providers' address space, right? So your host might pick up source address from one of ISPs, and obviously that packet needs to be routed to the right uplink. So we cannot just route based on destination, we need to take source into account as well. Similar cases, it's like traffic engineering or traffic segmentations in network like enterprises, when you have something like walled garden and you want some particular destinations to be reached through different paths, and return traffic needs to be routed accordingly. Again, in IPv4, quite often it was solved with NAT. In IPv6, we don't want to do this. So we want to make sure that we take source into account. So yeah, there are a few more cases listed in the draft as well. So next slide, please. So there are 2 or 3 key things about what the draft proposes. First of all, the draft defines the expected behavior. The specific algorithm of particular implementation can be different as long as the resulting output of that black box is exactly the same, right? So we defined what we expect, what the routing decision is expected to be. It doesn't matter how you get there. So also the idea is to first look at the destinations like traditional routers do, and then after the router selects set of particular routes which can be used to route that packet, the router could also look at sources. And because obviously we need backwards compatibility and we need to deal with situation when we do not care about sources, the idea is that source prefix of 0/0 should be basically, should behave exactly the same as we have routes with no sources. Again, the draft doesn't care how this is achieved as long as the behavior is the same. Next slide, please. So yeah, I do not want to go into the details because I want this presentation to be a teaser so you got curious and read the draft. But like in simplified description of what's happened, packet arrives to the router is supposed to find the most specific destination route. Nothing new here, right? So if, for example, we have 0/0/32/48 and /64 routes, let's pick up all routes which are /64. And after that, if it's, and after that, we'll look at the most specific source route, right? It might be that there is no route matching the given source, like on this slide, right? The packet source does not match anything we have in our selected route set. In this case, we repeat the process selecting the next most specific destination route until eventually you get the route which you can use. I guess in the worst case scenario, it's going to be destination 0/0, source 0/0, but maybe not. So next slide, please. Yeah, so basically why I'm here, I'd like people to read the draft and I'd like the working group to consider readoption call for this so we can move forward. I don't know if anything changes drastically in the world since 2019 when the draft was reviewed last time. Hopefully not, but if you think otherwise, please let us know. And comments, questions, suggestions, complaints?
I think since it's been a while, so I will encourage people to review it and see whether people are interested in this topic.
Hi, this microphone works. I'm Adrian Farrell. Thanks, Jen. You teased me. I read it. it's good to have this documented, and I see no reason why the working group shouldn't pick it up again. Thank you for the large interop section, and also the various notes about loop potential. I think that's important. I'd be failing in my life mission if I didn't note that this is something I would call semantic routing, because it's routing on something beyond simply the destination address. And that's great. So I'd encourage you to look at our challenges in semantic routing draft, which I suspect you will find pretty much apple pie stuff. But it should serve as a checklist of things just to go through and say, well, are we considering, for example, are we considering the amount of existing additional routing information that is going to get carried in the protocols as a result of doing this? And what are the convergence implications and things like that? And I think that's just worth thinking about as you go along.
Thank you.
Hi, Andrew Alston speaking just as a working group participant. Jen, so I've taken a very brief read of this document, and I just wanted to find out from the authors if they'd done any looking at what this type of routing could do to line speed in the forwarding plane, etc., and whether or not you've looked at if there are any implications and whether this can be done at line rate in the vendors, just to try and get a sense of where we're going and what effects this could have on hardware.
David, you.
David Lampater. To answer that, I did actually look at some of the silicon capabilities, and it varies a lot. For some silicon can do it, and they generally do it through the ACL engine, which is more limited than normal forwarding capabilities. But we don't have an actual good data set on this. This is basically just, I have a few data points only. And if anyone can add information on this, I would greatly appreciate that.
Yeah, obviously there is a, again, chicken and egg problem, hard to find how fast people can do things which do not exist and are not defined yet, right? So yeah, any feedback from vendors, hardware vendors is really welcome. So if you run into the mic telling me it's not possible to get it done at all, like, yeah, I'd like to hear that. Or if you're gonna tell me that piece of cake, we can do this, I'll be even more happy to hear that. So is it a good news or bad news?
So Darren Duke, Cisco. Yeah, it's varied depending on the hardware. For the type of hardware you're looking at, it's a doable thing.
Thank you. Made my day.
AC, you're next.
Yeah, AC Linux Cisco Systems. So I noticed that if you're doing this, you do it, you take the source as the most relevant key, as opposed to, so if this is the source routing overrides it. You do the source routing first, and then you do the destination routing.
No, no. We first look at the destination like traditional routers would do, pick up the most specific destinations, get a subset of routes for more specific destination, and then look if there is anything matching the source as a more specific source. And if there is an empty set, so nothing matching the source, you move to the less specific destination. Destination is first.
Okay, destination is still first. Okay, I don't see any problem with it then either.
Good, thank you.
Robin, you're next.
Okay, Jane, in fact, I'm a little confused about this work because, you know, we have the flow spec route or the ACL. When they do the forwarding, we will match the destination and the source, and not only destination and source, but also destination port and the source port. So I think the ACL or the flow spec may also satisfy the requirement. I'm not sure what's the difference between the two.
I think I need to think about that. David. Oh, David has an answer.
David Lampotter. FlowSpec is supposed to do rule-based like filtering, and it's generally applied in parallel. You wouldn't use FlowSpec to build a routing table normally?
Yeah, so I don't know, probably we could take it offline and think
Yeah.
about it, because I think I'm gonna say something really stupid if I start responding right away, right? So yeah, let's take it to the list, probably, if you can, Jean-Pierre, if you can send this to the list, we'll think about it. Thank you.
Thank you, Jen. Tommaso, you are next.
Hello, can you hear me?
Yes.
Okay, let me share my screen. Is the screen sharing?
Yeah, I granted the
Okay,
share.
okay. I'm okay. Okay, hello. My name is Tommaso Gagliazzi, and I'm a PhD student of computer networks at Rtgwg University, and I'm here today for presenting you CBIL, a framework for evaluating the implementation of routing protocols in FAT3s. This is a joint work between Rtgwg University in Italy and the Università della Repubblica in Uruguay. So what is the problem that we tried to solve? Well, we know that data center networks are complex and characterized by high density networks and with a wide variety of routing protocols with heterogeneous implementations and devices. Moreover, we know that a great part of the failures in these networks are caused by software bugs or configuration errors. And in this context, we found a lack of standard testing procedures and tools for assessing routing protocols. And this motivates an effort in developing solutions for such a critical task. So our goals were principally two. First, to define a methodology for testing routing protocol implementations. And second, to develop a framework that implements the methodology and that can be exploited to test real routing protocol implementations. We focus on data centers since they are the core of the modern internet infrastructure, and we analyze FAT3s since they are the most used topologies. However, the framework can be easily modified to support different class-based topologies. The aim is to verify the real implementation's behavior and not to measure their performance that heavily depend on hardware. Before starting with the methodology, a bit of notation. We adopted the terminology of the Rift draft for describing a FAT3. So we have top of fabric in the aggregation layer. Pods are composed of leaf and spine nodes. We have that k-leaf is the number of interfaces of a leaf pointing to the spine, and that k-top is the number of interfaces of a spine pointing north or south. Finally, we have that R is the redundancy factor. So our methodology is based on the following milestones. First, FAT3s have regular characteristics, and this allows to focus on specific elements to obtain results with a general value. Second, performing tests that measure the actual times can be misleading since timings heavily depend on the used hardware. So we try to evaluate the implementations being oblivious as much as possible with respect to the actual timings. And this also allows a normalization of the test results independently from the execution environment. Third, since routing protocol can be conceptually very different, we adopt a black box method that is regarding as much as possible the internals of the implementations. The methodology defines two main test categories, failure and recovery. Failure tests induce many types of common faults in data centers and measure how implementation reacts to those faults, while recovery tests measure how implementations react when the network is restored from a fault. To cover all the failure and recovery cases, we define a failure and recovery test for each type of node and for each type of link. For each test, we analyze 4 main aspects: the convergence, the messaging load, the locality of the event, and the rounds. That is a novel metric that will be explained after. The first aspect we considered is the protocol convergent, and obviously the aim is to check that after an event, the nodes data plane forwarding table reach the expected state. The second aspect is the messaging load. The purpose is to determine if the protocol overhead grows smoothly with respect to the topology parameters that are the values of k and r. To evaluate the ability of an implementation to limit the blast radius of a failure or a recovery event, the methodology defines a locality metric that is computed with the following algorithm. First, we count the number of packets that traverse each link of the network. After, we assign a topological distance to each link computed as the distance from the event. And after, we compute the total number of packets received at a certain topological distance. The result is a vector where each element is the number of packets captured at a specific distance. And we summarize it into a scalar value, giving a larger weight to packets that are flagged from the event. The way locality is considered allows to perceive the blast radius of an event, but it doesn't give any information about the number of rounds when this happens. Packets could be received all at the same time or in different timings. However, considering this aspect being oblivious as much as possible with respect to the actual timing is a challenging task. And to do that, the methodology introduces a novel representation that describes how the states of nodes are synchronized by routing protocol packets. We call it node state graph. Here we have an example of a k equals 2, r equals 2 fat 3, and a node state graph relative to an event on this topology. A node in the graph represents a switch of the network in a certain state, while an edge represents a set of packets from the upper node that contributes changing the state of the lower node. In particular, this node state graph is the one generated by a leaf node failure on a BGP implementation. To compute the node state graph from the outside, we use an intermediate representation called the node state timeline. So let's consider our usual example of a leaf node failure on a BGP K2 R2 topology. We will see how we can compute the node state graph starting from the timeline. To construct the timeline, we considering the signaling PDUs captured in the network during the event, that are updates packets in this case. And then for each node, we order the PDUs by their local node time. Packets are then partitioned into sets of consecutive sent packets called sending group and of consecutive received packets called receiving group. This operation is executed for all the nodes in the network. Now let's consider spine 1-1, that is the first node to react to the failure. Its sending group corresponds to the initial state of 111 in the node state graph. It sends 3 packets that contribute to change the state of leaf 102, TOF 121, and TOF 122. The same thing can be applied for spine 112. Now let's go down in the intermediate in the graph to the intermediate node leaf 102. Its state is composed of a pair of receiving group and sending group in the timeline. Its sending group is composed by 2 packets sent to the spine in the same pod. So we create an intermediate node in the graph for each node that presents a pair of consecutive receiving group and sending group in the timeline. Finally, let's consider the nodes at the lower level in the graph. Their state is composed by only a receiving group because no other transmission are needed in the network for handling the failure. Okay, we now know how to build a node state graph, but what can we do with it? Well, this graph allows to perceive the number of state changes that the network traverses before the convergence. We call these state changes rounds. And using the graph for each vertex, we can compute the number of rounds as the length of the longest path from a source to that vertex. And we call this measure state round value of a vertex. Moreover, we can compute the maximum value among the state round values of the vertices, and we call this state round value of the graph. And in this example, it is easy to notice that the state round value of the graph is 4. Okay, now I have introduced the methodology a little bit, so I can start to talk about CBIL. CBIL is a software framework that implements the methodology leveraging on network emulation to run real software implementation. It allows to automatically deploy and run repeatable tests on virtual fat trees, allowing to build a testing pipeline on data center networks. CBIL already provides all the code base for the test described in the methodology and some basic templates that can be easily extended to create custom scenarios. For doing this, CBIL presents some utilities and callbacks to interact with the nodes of the topology. The CBIL architecture presents high levels of modifiability and assemble existing tools with new ones specifically devised for the purpose. For the network emulation, we choose Katara. Katara is a container-based network emulator developed at Rtgwg, and we choose it since it can leverage on Kubernetes for the virtualization, and thence it is able to scale up in a cluster to faithfully emulate large-scale networks. Okay, but how does it work, CBIL? What it do during an experiment? Well, basically, it generates and deploys the topology. It starts to capture all the PDUs, and then it starts the routing protocol. After it performs the required action for a specific type of test, like a node failure, and then it performs the convergence check to ensure that the protocols has converged. After it shuts down the containers, and then it performs the analysis on the dumped traffic, outputting the results with all the metric and some novel and some graphics, interactive graphics, to monitoring the network. Okay, but what can we do with CBIL? Well, there are many possible use cases, and in the following we will see some of them. A first possible use case is the complete analysis of a routing protocol implementation. As example, we decided to analyze BGP since it is the de facto standard for closed-based data centers, and we choose the FR routing BGP implementation. We executed all the tests of the methodologies on topologies up to 1,280 routers and more than 33,000 interfaces. In the next, I'll present you only a summary of the results, but you can find all in the repository and in the paper. So from a messaging load perspective, we found that implementation does not manifest any performance degradation varying K and R. Moreover, we found that the number of packets exchanged by node is not affected by the number of nodes in the network, but it only depends on the number of interfaces of that node. On the locality side, we have that the implementation floods all the nodes when an event happens in the network. And finally, from the rounds analysis, we have that the FR BGP shows a very stable behavior. In fact, given a specific test scenario, it requires the same number of rounds to converge, and here the topology size does not matter. I want to show you only an example of the graphs automatically produced by CBIL. These representations are very intuitive, and they can be exploited to reason about locality and rounds. On the left, you can find a topology labeled with the number of packets that traverse each link during an event. And this could be very helpful to think about locality. For example, we can easily notice that exactly 2 packets are exchanged on each link. On the right, we have a node state graph. It presents a maximum round value of 4. And we found this value on all the other topologies for a leaf node failure. This graph is interactive, so you can find information about the packets that contributed to change a node state by clicking on nodes or edges. A second possible use case is the developing and testing of prototypes. Here we focus on Rift Python, the only open source available implementation of Rift. Rift is an hybrid link state distance vector protocol that aims at minimizing configuration and operational complexity. It includes some novel mechanisms, such as the negative disaggregation, which allows the automatic prefix disaggregation in case of failures. And during our analysis, we found some scalability issues which are expected since the Python implementations aim only to ensure the correctness of the draft. Moreover, with Python, we found that with Python was missing the negative disaggregation feature, so we decided to implement it, building a testing pipeline on Civil to test all the code changes in all the scenarios. We also verified the interaction between nodes, leveraging on timelines and on the node state graphs, and this was a very valuable support during the development. Moreover, since our metrics don't consider temporal tied aspects, they are also suitable for evaluating prototypes. In the paper, you can find a comparison on how this Python performs against Rtgwg on the topologies where the implementation converges. We found, however, that with Python, even if it's a prototype exhibits good results, showing the credible potential, especially from a locality point of view, as you can see from the pictures, where in case of a leaf failure, Rift only flutes the nodes inside the pod where the fault happened. A third possible use case is the test of flooding reduction algorithms. Recently, there has been a lot of effort to develop flooding reduction techniques for data centers, and Sibyl can be used to compare and evaluate the flooding reduction algorithm implementations. We perform a comparison between a Ferrara ISIS and the Ferrara OpenFabric, an ISIS modification that aims to reduce the flooding in a leaf spine topologies. You can find all the results in the repository. Here, for time reason, I only show the node state graph for a leaf node failure on a K2R2 topology. And as you can see here, the effects of the flooding reduction are easily noticeable with the node state graph of OpenFabric that becomes a tree. Other possible use cases are the bug. I finished. Sorry. Are the bug and inefficiency inspection using the node state graph. You can find an example of it in the paper where we spot some inefficiencies in the Juniper Rift implementation. Also, we have the verification of protocol configuration and the test of interoperability between implementation of different vendors. I am at the end, so thank you for your time. Here you can find some useful links and some contacts. You can find also the mail of Mariano, that is the colleague I work with on the development of Sibyl. If you have questions, I'm happy to answer, but if we are out of time, feel free to contact me in private or send an email also to Mariano. Thank you for the opportunity to be here.
Tony, go ahead.
Yeah, let me talk clearly. Tony P. Juniper. Full disclosure, I mean, I work with them pretty closely since quite a long time. I highly encourage people who are heavy into routing protocol, especially implementation, to have a deep look at this stuff, because this goes far beyond a framework that allows you to compare, protocols and find interesting bugs. So, they kicked a couple of things out of my implementation, which stuff was working just fine. And we didn't look for like correctness. We were looking for correctness in terms of ultimate that the thing converged, timing, and so on, that they found stuff that were due to protocol inherent self-stabilization was working fine, but was not efficient, right? We were like retransmitting too often, something like this. So that's very applicable immediate interest, but the framework they're building is actually allowing to observe this distributed system in a very formal way, like Leslie Lamport kind of vector clock graph, if you do it. And that could lead us to a point where we actually can start to think whether formal proof of correctness of routing protocols is viable. Because until today, we just don't know. OSPF converges, yes, but who said? We don't have any formal proof. BGP, we all know, I mean, stable oscillations and so on. And this kind of framework gives us access to an algebra, which is a complete game changer, right? So I highly encourage people to like at least read the paper, or otherwise just kick off Katara. It's a phenomenal framework. Lots of people are using it in the container world. But the scope of the stuff is bigger than just some new nice graph and a little bit comparison of protocols. So this is the immediate use. Yeah. Thanks.
Thank you. Thank you. Many thanks, Tony.
Pascal, go ahead. Yeah.
Hello, Tommaso. This looks really neat. You said that you implemented the negative disaggregation and didn't get much feedback on it, and whether it's really useful and whether it performs. And since you mentioned it, I mean, I would have liked to see how it improved the situation or made it worse. I mean, did the negative disaggregation really perform as expected? Was there some surprise about it?
We never tested the negative disaggregation using the Rift implementation, so using the Juniper implementation of Tony. So I don't know, because in the Rift Python, yes, it works as expected when implemented it, but this implementation is written in Python, so it converges only on very small topologies, and I think that we cannot state that it's working well there. However, if you want to talk about this, send me an email, please, Pascal.
Tianji, you want to ask a question?
Tianji, China Mobile. Here, well, looking at you are showing a picture. I forget which one, but probably the first. It's called the factory notation. The things for the cloud data center or enterprise data center, actually, there are multiple plans. The first is just is not restricted to only one plan. The second part is you're now showing is like a virtual port channel, like a Cisco or Brocade. They have a virtual fabric, Arista, MLAG, CLAG, Extreme, all kind of things. So when you consider the thing together, a standalone like a leaf span, super span node will not be considered by itself only, actually going to be aggregate. In that case, see, I have to acknowledge I haven't read through your work, but from your presentation, it seems you put everything by itself without considering the fault tolerance mechanism that have been put into the cloud or enterprise data centers. So if with that one insight, so have you ever evaluated the impact of criticalness of your work? Thank you.
Thank you.
Jeff, you want to say something?
Yeah, I just wanted to encourage Tommaso to continue this work. I'm really happy to see this here. And I hope to see the team on regular basis updating us what has been tested. And so obviously you will see more comments coming from more enterprise people. So the comment about of use MCLock is proper one. And if you have more time, probably could look in less hyperscaler topologies into more enterprise topology. But practically, it's really good work, and thank you for doing it.
Thank you. We will sure continue to work on this.
Thank you for the presentation. So I just want to bring people's attention. This is not a draft-based presentation. If you are interested in the framework, you can contact Tommaso directly, or you can send questions to the mailing list. Thank you.
Thank you.
Hey, just a quick one. You want to post the links on the routing working group list, because in the PDF version of the draft, there's no link for the paper and everything.
Links to the paper and to the repository and all the works in the presentation.
Hello, can you hear me?
Yeah, go ahead.
Oh, okay, thanks. Hello, everyone. This is Wen Yin from China Mobile. I will present the SRv6 multi-homed egress protection. Next slide, please.
You have control yourself.
Oh, okay.
Bottom of your screen.
Okay. This draft provides a simplified protection mechanism of fast failover for multi-home egress scenarios. The main point of this solution are as follows. Firstly, carry the seed of the backup egress in the SIH last entry of the packet. Secondly, expand the SIH flags field to indicate that the backup seed is carried in the segment list. Thirdly, when the penultimate endpoint receives the packet and finds that its next hop direct label is the egress node and is unreachable, it changes the destination address of the packet to the backup seed. Okay, this slide shows the extension of SIH flags. We define the B flag in the SIH flags. If the B flag is set to 1, a backup seed is carried in the segment list, and only when the penultimate endpoint receives the packets with B flag setting, it will execute the egress fast switching process. If the B flag is set to 0, backup seed is not carried. This is the procedure of multi-home egress protection of SRv6T path. As shown in the picture 1, PE1 is the ingress node and P3 is the primary ingress node. P4 is a backup
Are you sharing
egress
slides?
node.
Are you sharing slides?
Oh. Can you hear? Can
you share the slides?
I share the slides.
We are sharing
Yes,
slides.
yeah, we can see the slide.
Can you see the slides?
Not
Yeah,
see.
yes, I can.
There were also another
Oh,
comment
sorry.
that
Wing, please continue.
Oh, okay. This is the procedure of the multi-home egress protection on SRv6T path. In this, as shown in the picture 1, PE1 is the ingress node, and P3 is the primary egress node, and P4 is the backup egress node. When the ingress node P1 encapsulates the SIH header, judge whether the primary VPN seed of the egress node has a backup seed. If yes, insert the backup seed into the position of SRH last entry, and set B flag to 1 to identify that the backup seed has been carried in the last position of the segment list. Then the value of SL is set to n minus 1. N minus 1. Normally, the traffic is forwarded along the path P1, P2, P3, and C2. When the P3 fails, P2 finds out that the PE3 seed is unreachable, and the B flag value is set. The P2 modified the destination address of the packet to SRH last entry, which is the backup seed, and sent the modified packet to backup egress node P4. Through this method, P2 can provide fast protection for the egress failure. Okay, here is an example of SRv6T path scenario. When PE1 receives the packet from C1 to C2, P1 encapsulates the packet with IPv6 header and inserts the backup egress seed A4 colon 100 into the position of SIH last entry. The segment list in SIH is designed as A11, A21, A3 100, A4 100. The SL is set to 2. The last entry is set to 3, and the B flag is set to 1. When P2 receives a packet destined to end.exit A2 : 1, in normal operations, it forwards the packet with source A0 : 1 and the destination P3's VPN seat A3 : 100 from the link between P2 and P3 according to end.exit. When the P3 fails, P2 receives the packet to be sent to A3 : 100 and finds that the outgoing interface is down. If the B flag is set in, P2 changes the destination address of the packet with the backup seat of SIH3, removes SIH extension header and sends the modified packet to A4 : 100. When P4 receives the modified packet, it decapsulates the packet and forwards the packet by executing end.dt6 behavior. This is an example of SRv6 BE path scenario. The multi-home egress node protection processing on the SRv6B path is consistent with that on the SRv6T path. The only difference is that when P1 encapsulates the packet with IPv6 header, only the active seat A3 : 100 and the backup seat A4 : 100 are filled in the segment list of the SIH header. The SL is set to 0, and the last entry is set to 1. The B flag is set to 1. The active seat A3 : 100 is used as the destination address of the outer IP packet header. Once P3 fails, the penultimate endpoint P2 finds out that the route to the directly connected egress node P3 is unreachable. If the B flag is set in, modify the destination address to the backup seed A4 : 100 in SH1 and send the packet to the update destination address. Okay, that's all. Any question or comments are welcomed.
Aihua, please go ahead. Please be brief because we are running late.
Okay, can you hear me?
Yes.
Yes.
Okay, just a quick question. What's the improved performance of this fast ingress protection? Did you invalidate with running code?
Oh no, we have.
So
have no running.
hello. I'm also Carlson, and I would like to respond to you. So I think we have already worked with some of our vendors to have a protocol, a prototype, and it works very good. The switching, the protection switching performance is also very good, less than 50 milliseconds. Thanks.
Thank you for the presentation. We'll go to the next one.
Oh, thank you.
Zhibo, are you there?
Hello?
Go
Hello?
ahead. Yeah.
Can you hear me? Okay.
Yes, I can hear you. Go ahead.
This topic is about SRv6 midpoint propagation. Next page, please.
You can flip through yourself. Bottom of your screen.
Okay. SRv6 TFA can achieve top-bridge independent fast routing. However, it cannot cover SRv6 policy endpoint node failure. For SMPS, there's already a document which can provide endpoint protection. This document introduced an SRv6 endpoint protection mechanism. When an SRv6 endpoint fails, an SRv6 proxy forwarding node can replace the failed endpoint to perform SRv6 endpoint function, forward packet to the next segment node. Next, I will introduce SRv6 midpoint protection mechanism. Strictly path scenario. When node D is failure, enable node C performed for packet forwarding, offset the SLR to the next segment, and send packet to the next segment node E. Loose path scenario. When node D is failure, because enable node C isn't an SRv6 endpoint node. In this version, we modify only endpoint nodes can perform proxy forwarding. So node C can't perform proxy forwarding. After IGP convergence, node B deletes the fib to D. It will check fib miss and perform the proxy forwarding action, offset the SL to the next segment and send packet to the next segment node E. Previously, we collected feedback from the Spring working group. Chance node perform proxy forwarding will modify SH, which is against RFC 8200. In this version, we added a restriction. Only SRv6 endpoint can run the midpoint propagation, and the chanced node can do this. This document has been discussed for a long time and is clear to everyone. We have resolved all the issues. We have collected valuable comments from Bruno, and we have slowed it by adding the restrictions. We would like to move forward this document. Thank you. And that's all. Any questions?
Do I have questions? Otherwise, we'll bring it to the list because we are running short on time. Loa, you want to say something quick?
Okay. I just wonder why this is in the Rtgwg working group.
Sorry, I didn't hear you.
Can't hear me now?
Okay, can you bring the question to the list, please? We'll start with the next presentation. Thank you.
Hello. Can you hear me?
Hello, can you hear me? Yeah, this is
Jeff, we can.
yeah, this is Feng Yang from China Mobile. Feng Yang from China Mobile. Yeah, we are talking about some use cases for SRv6 as the computing resources interconnecting protocol. So background is that we have nowadays we have a large scale of collaboration between different partners. There are central cloud, edge cloud, and also some private cloud in customer site. So hopefully some days we can see the cloud services will be as the same as electricity and water provided to the customers. So that's our vision. Some days maybe we can reach that. So now we want to make some use cases to clear to everybody what we are doing and what we are doing now and what we want the network to be in the future. So computer resources are connected by the networks and served to different verticals and end users, cell phone customers, home users, and enterprise users. So it needs to provide some differentiated and deterministic SLA guaranteed capabilities. So now we are as China Mobile building the network mainly for all of the computing resources distributed around China. That's a new network, which covers almost 300 of cities in China, almost 90% of the cities in China. So what we want to do is to unify the protocol of the IP network. So make the collaboration between at least between the network and the cloud easier. That's to simplify the networking technology and also to enhance the cross-domain scheduling ability. So the picture shows very simple architecture. That is, we have unified network running unified SRv6 protocols, and that connects the computing resources, and also for the computing resources is kind of central cloud or the edge cloud. Even it can be the private cloud in the customer side. And those computing things will serve to our customer. So based on this, we have some use cases. The first one is we need to provide a differentiated services to customer. The potential solution is to calculate different paths to, for example, some high bandwidth, low latency acceptable paths to serve our customer requirements. The second one is in case of the bandwidth utilization goes high, we need to some kind of isolation between different classes of services. The potential solution is we can have some kind of slice. The slice can be just like some kind of topology, serves to different kind of class of service, and also can be some kind of hard slice that have some of the resources, queue resources or memory resources reserved for different slices. Then we need to, the important thing is we need to the cross-domain ability, which in China Mobile we have we have provinces network and also has backbone networks. We need to end-to-end to connection. Then we need a cross-domain ability. The potential solution is to have the connection abstracted as the BSID and open it to the high level of the application. The application will put all of the BSID together to form an end-to-end connection. Then we have to need to consider to put the connection and the computing services together, and so we can use SRv6 again to do both of the connection, and also if some of the computing services like some firewalls like that they can be SRv6 enabled. It can be put into the SID list. Then the fifth one is the application. We need to understand the application. At least we need to categorize the application to provide the different kind of the services. And we also need to have some operation and OM capability to understand the user experience. So for example, here we have just show the SRv6 IOM here to get the quality and also to locate the failure when it happens. The last one is the SRv6 overheads. We have the picture here and it shows the network. It has more than 7 hops in end-to-end SRv6 paths. So the overhead is high here, especially for some of the online meetings with average packet length around the 300 bytes. So we need to consider the SRv6 header compression. So that's all.
Linda, yeah.
Thanks.
This is Linda Dunbar from FutureWay. So I do have questions that you mentioned about the computing, aware of the computing, aware of the user. And so is this related to China Mobile's CAN, the compute aware networking? Is it part of that initiative or it's different?
It's part of the networking, just networking. It's different.
So you're not considering like advertising the computing resources to the ingress? That's not part of this?
That's not part of this.
Okay, thank you. Just to confirm.
Yeah.
Tony, you're next.
Thank you. I'd appreciate a clarification on your problem statement. We already have cloud computing that's ubiquitous today. It works just fine with best effort services. What is it? What's the problem you're solving?
We are solving. First, we need to provide differentiated services to our customer. For example,
why?
one network.
You're begging the question.
Because of the different, the different kind of the customer have different of the delay requirement and the bandwidth requirement. If we put them together.
What breaks if you use best effort?
If we have the best effort, only have best effort, then in case of the bandwidth utilization goes high, then we cannot provide the assured service to customers. That's a problem.
That seems like a provisioning problem.
Sorry?
That seems like a provisioning problem. Your cloud
Not
doesn't
at
have
all.
enough bandwidth.
Not at all, because most of the access network and also not, some of the networks, they are the topology of the access network and aggregation network, they are some form of the tree. So in case of the that way, then there must be some kind of congestion happened in the root of the tree.
So if you've created a purely hierarchical topology, then you have a choke point, and that seems like an architectural issue.
But it's not possible to build a full mesh network. The cost is too high. It's possible
We've been building distributed networks for many decades.
Yeah, so we want to solve that problem by just using existing network architecture and providing more ability.
Okay, can you please continue the discussion on the list? Lin, you have a question? Please keep it short.
Lin Han from Rtgwg. Quick question. So how do you define the computer resource? Is it just by name or by 5 tuples of the address and ports? Thank you.
Computing resource can be kind of a central cloud or the edge cloud. We need to connect the edge cloud and the central cloud together and in kind of a flexible way.
Okay, Daniel, you are the last one. Please keep it short.
I already get the answer from the questions, Linda. But I still would like to strongly recommend the authors to consider about the computer world network scenario. Thank you.
Okay, thank you.
Yeah, go ahead.
This is GPT, so sometimes we go into some animation for our a little bit more slides. Okay, checking. Hello, good morning, everyone. Tianji here. On behalf of all the authors, I'm talking about problem and requirements of satellite constellation for internet. The work has been, I think, has been talked in. Still the previous. Yeah, the work has been talked twice. This is the version 3 from some changes. Can you the next one? For this is agenda. Well, just for the first two big bullets, so just try to give a little bit of background about how significance of the work. Basically the satellite requirement and some problem statement there. And for the third and the fourth, the bullets is about what has been changed, and then what will be the next. Next slide, please. Thank you. Okay, here just give the background about all the 3GPP related tech documents that will be important or critical for the success or as the foundation for the work in the draft. For the last two bullets is mentioned as SA2, that is the 3GPP working group. Those are two ongoing the study projects have been explored and studied in 3GPP side. One is the 5G use satellite as the backhaul is from the GNOB toward the core net. The core network is a mobile core network. And the other one is satellite as the access network. So basically it's from on the RAN side toward the GNOB. Okay, here, this one, this is actually the new, the change added to the version 3. This is very high level diagram from 30,000 foot bird view. It's about the satellite insertion point on the 3GPP wireless access part. The first, the top diagram is showing the satellite network is after the mobile access, but it's before the internet. Well, the bottom part is showing the satellite is on the access side. So basically from your end device and go through the satellite and then go through the mobile access. So the next slide, I'm going to, I'm going to explain what this means. For the top left, it's just like very simple things, and then you can consider the satellite as a reflector. It's hanging around on the sky and give you a simple reflection. And the top right one is about regenerative. It's for normally for large areas. Okay, but in the top right, it start to include the multi-ISL in the satellite link. Well, for the bottom left is actually is like the access part. So you have the GNOB. Sorry, you have the DU, GNO, CU. Those are the wireless, the base station part, and then one on board on like a DU on board on satellite, and the CU is on the ground. But here there are some big challenge regarding some timing things like for the wireless, you have to get some slot within some timing budget, like 1 millisecond, and you use some super frame, those type of things. To split into a different sub, slot. So this one really pose some challenges. So for the box toward the bottom right, the thing is, well, for all the three bullets here, the middle one is important. Just to say, okay, for all the work here, it's critical. For the 3GPP, it has set up the projects. And then the 5G commercial deployment is there. I think it's close to 2 million 5G base stations already, lots of applications. And then satellite is important. So in order to do that, the satellite network is, some standardized work need to be done. Can you go to the next one? Yeah, here is on the layer 3, just to show, okay, well, if you consider a satellite as a node hanging around on the sky, and then how the IGP, potential EBGP, IBGP, those type of things will be appearing together. So for the work that has been talked in previous IETF, 1.1, I think 1.1.2, I forget. So previous to talk about how extreme dynamics in the red font toward the bottom left, about all the link quality, cost, all kind of things, and the IGP, BGP mutual advertisement. So here is really the challenging part for the layer 3, especially for the LEO, the low Earth orbit satellite-based network. Okay, now back to the draft here. This draft is the third version of the second bullet in the top box. That's actually the first bullet in the top box is the red font. And then this is one of a series of IDs on the satellite networks. The things have been discussed in previous IETFs. Can we, after I'm done?
I have a clarification question on the last slide. It's really brief.
Okay.
This is Dino. So it kind of makes sense that from ground to space, you're using EBGP, but it looks like you're using one single IGP for the entire satellite network. Is that supposed?
No,
was your,
this
was
is
your
a
intention for it to be a single AS or multiple
No,
AS?
this is just a conceptual. I'm not showing, okay, I can only use one single or multi, those type of things. Just conceptual.
That wasn't
things.
implying one AS.
Yeah,
Okay.
just conceptual things, yes.
Actually, I can answer that. That slide doesn't mean that we will use that. It means that by traditional technology, looks like we have to configure BGP somewhere, either from the ground to a cellular link or somewhere else to interworking with internet. That's why there's a problem.
Okay. By the way, Lin is the chief editor of the draft. So yeah, here is the bunch of the IDs. Okay, and then here these are two cases from the 3GPP. That means it's a real things that being studied. It's so far is in the stage 2. After the down of the stage 2, we going to trickle down to stage 3, and then about the all the kind of communication protocols, all kind of thing will be involved. Can you go the next one here? Yeah, well, this is a case to show, the layer with multi-SL as a 5G backhaul. And then, it's, well, basically just say, suppose you have two UEs who anchor on different UPFs. And then when they want to talk to each other over a session that spans more than 5 minutes, and because of the extreme dynamics of the satellite, it will cause some, I will see very significant challenge to the things. So for, and also, for the, this one will include the QS flow, since for the 3GPP, each UE will have a PDU session, and then QS flows, all kind of things will involved. So if you consider things together, like suppose from UE1 to UE2, it's going through the layer 3. So you're going to involve the routing, the extremely dynamic routing protocols, routing algorithms with the QS inside, and also the 3GPP case talking about monitoring. You have to get some feedback from the network in order to adjust or improve it. So when you put everything together, so this is very important and critical to justify why a satellite network is important, and it has some position in IETF to do some SDO work. And then the second bullet on the bottom box is just to show, dynamic does not mean anything about the random. So it actually, the track of a satellite actually has some predefined tracks. So you may, or we may be able to utilize those information in order to do the mechanical work. So the next. Yeah, that's it. Yeah, so this is just a conclusion about the other things. And then, we have, this is the third time. And then we hope, oh, by the way, there will be a set meeting in next in UK, London for IETF 115. And we do welcome all the comments, contributions, and, all kind of the feedback. We believe it's important, and the real case is there through GPP are working on it, are pushing it. Okay, thank you.
Dino?
Yes, this is Dino. With respect to the instructive routing draft, do you guys, from all the research you've done so far, have you, do you believe or have an opinion if GPS-based routing will be done on the satellite network?
Okay, Lin, can you answer for that part?
Actually, that's just one solution we're giving, but we know that there are many research topics for this regard. So I think we welcome other people also contribute different solutions, because that's not an easy routing problem.
Thank you.
So based on that answer, do you think you're going to have to interwork between these different solutions?
You mean the interworking with a different network? With the internet, of course, you have to.
No. If you have multiple addressing solutions on the satellite network, will the satellite network systems have to interwork with each other in LEO?
Right now, we don't expect there will be interworking between different satellite network. But one satellite network has to exchange internet routes with internet.
Yeah, it's a different level.
Yes, it's different level. Yeah.
Okay, so to summarize that answer, you're going to say each satellite network that has a different addressing scheme will look like just a different type of layer 2 link, and to make them work, it's no different than Ethernet or FDDI to talk about the past links, and you just L3 over it.
Yes, that's what we can see right now, because we cannot force a different vendor to use one technology. But bottom line is that satellite network has to be IP compatible, because in 3GPP point of view, they will treat every satellite network as a IP node.
Yeah, so there's obvious disadvantages of that because that means there's going to be a lot of ground to satellite delay.
So we only have 1 minute for the second to the last presenter. We apologize to the last presentation. We won't be able to get to it. We'll have an interim to cover that. Shai, please go ahead.
Yes, thanks. I will give a quick break. And I will present the two use cases. And in carrier networks, operators may change the page. Yes. Operators may deploy multiple data centers or computing resource pools distributed. These data centers can house different types of value-added service. From the perspective of an operator, we need to think how to provide better services. In addition to the cost of latency of network process between the data centers, whether computing resource should be considered, and how to measure computing resource, the number of virtual CPU or CPU utilization, memory utilization, or other parameters, and what the technology is used to achieve computing aware function. And I will talk about the two use cases. One is computing aware SD1, and the other is computing aware SFC. Yes, if SD1 can be aware of the computing resource of an application deployed in the cloud by virtual CPEs and selects the application instance for the client to visit according to the computing power and the network state of one. As shown in the page, client 1 and client 2 visiting application 1 in cloud 1. If the load of application in cloud 1 is 50% and the load of application in cloud 2 is 20%, and the same network state, how about client 3? And we think to consider, let's say loaded the application SD1, select the application 1 in cloud 2 for the client 3 in branch office. So the path is shown in the page. And the other case use cases is about computing aware SFC. Yes, we can see each data center may have different types of service functions. High usage service functions are deployed in edge or regional data centers, while other low usage service functions are deployed in global or central data centers. So SFCs with different types of service functions may span multiple data centers. When we consider the path computation of SFP according to the cost of or latency of network passes between the data centers hosting the service functions nowadays, in order to get the good service experience of service functions and the optimal end-to-end network path, the computing load of service functions should also be considered. As shown in the page, a user orders SFC with a chain of two valued added services for its access to internet service. The service sequence of the FCC is to access firewall and the VO, which DC is better to provide the function firewall. To consider the laterally loaded service functions, the computing SFP is represented as in the page. And we have mentioned the procedure for SFP creation in the draft. And we also to give the potential solutions could be considered. Maybe to collect the service functions location and computing power by BGP, LS, or NAT config from the router connecting the data centers, and dynamical get get the association relationship, and independent collect the service function, location, and computing power by other means, and statically configure the association with the network on the control plane.
Sure, we are 5 minutes over time. I think we really need to close down.
Okay. We just to solicit comments and refine the draft, and we wanted to see are there any other parameters to be considered and any better solutions. Thanks.
Okay, so thank you for the presentation, and we don't have time for any questions. Sorry for the delay and all the technical hiccups. And we will, for the unfinished presentation, we will have an interim in London also for the request that didn't make on the slot. Thank you for joining the meeting. We'll see you in London.
Thanks everyone, and hope to see you soon. Bye.
Bye, see you in London.
Yesterday, I forgot to ask you a question for your satellite.
Did you come to my presentation?
I did,
Oh,
but
okay.
someone asked me left.
Bye,
I
bye.
thought
No
it
worries.
was it.
No worries. Okay. Because it's another underlay.
Yeah, I understand that.